Okay, so last week we talked about what positive slope looks like, what negative slope looks like, what a zero slope looks like, and what an undefined slope looks like. But this week we're going to start actually trying to figure out how we calculate the slope of a line and how we can assign a number to that. Because even though you could have a positive or a negative slope, a line with a slope of +3 is different from a line of slope of +4. So we got to be able to figure out all these different slopes and how we can calculate them. So the first thing I want to say is that the letter we use to represent slope in a line is the letter M. I don't exactly know why that is, but that's the letter that we use to represent slope. I'm sure we could figure that out, but I don't know. And so the slope, which we represent by M, is calculated by taking the change in y divided by the change, oh, I forgot a letter there, change in x. And luckily we have a line right here, so we can use the graph of this line to calculate the slope just by counting the change in y versus the change in x. And if you have a line, a graph of a line, especially if you can see points on the line that are like right on an intersection point here, it's really easy to calculate the slope because you could just pick 2 points. Let's say we pick this point and this point. You could really do this for any points on the line, but let's use these two. And you calculate the change in y divided by the change in x. And when I say change in y, I mean how much the line changes going up and down. That's the direction of the y-axis. And when I say change in x, I mean how much is changing left to right. We're always going to be moving left to right along our line. So change in y. I want to go from this point to this point, but first let's see how much we move up and down on the y-axis. So we go 1, 2. So the slope of this line is going to have a 2 on top. And then how much do we change going left to right on the x-axis? We just go over 1. So it's just 2 over 1 equals 2. And this line has a slope of 2. And that makes sense because we knew it's going to be positive. So it should be a positive answer, and we got +2. And the change in y over the change in x is 2 over 1. Now, what if we picked 2 slightly different points? Like, let's say I started with this point, and then I went all the way up to this point. Do you think the slope is going to be the same or the slope is going to be different? Well, we're going to use the same formula, which is change in y over change in x. So let's see, we're trying to go from here to here, but first I'm going to change on the y-axis. So I'm going to go up 1, 2, 3, 4. That's the change in y is 4. And then on the x-axis, going left to right, we go 1, 2. So 4 over 2. Now that might look different, but 4 over 2 is just 4 divided by 2, which is the number 2. So actually, whatever points on this line that you pick, you're going to get the same slope. Okay, so let's take a look at this one. This line, you should know by looking at it that the slope is going to be negative. But let's calculate it using the formula that we learned, which is slope equals change in y over change in x. And slope, again, is the letter M. And I'm going to show you something new here. And sometimes you'll see this written in math textbooks. Instead of writing change in y, they'll write this little triangle symbol, which is actually the Greek letter delta, but it just means change. So this really means change in y divided by change in x. So if you ever see this formula, that's the same thing we've been doing. It just means change in y over change in x. Okay, so let's do what we did before, where we picked 2 points on the line. So I'm going to pick this point here and this point here. So we want to find out how much this line is going up and down, that's change in y, and then how much is going left to right. So we want to go from here to here. So up and down, this line's going 2 spaces down between these 2 points, 1, 2, and then, so my change in y, it's going down 2, so I'm going to write that as -2, and that's how we get the negative value in this line. you should know that this line is, the slope of this line is negative because we talked about this last week, but that's where this comes from because it's going down 2 spaces. So -1, -2. And then left to right, it goes over 1, 2, 3. So it's -2 over 3. And just like we did last time, you might ask, well, what if I pick 2 different points? Okay, let's pick the same starting point, but let's pick like this point down here as our second point. And I don't know if I made this clear, but I'm trying as best as I can to pick points that are nice and neatly on the grid here, so it's a nice even whole number and we can count it easily. So let's calculate the slope with these 2 new points. So we want to go from here to here. We go down 1, 2, 3, 4 spaces. That's -4. And then we want to go over 1, 2, 3, 4, 5, 6 spaces, -4 over 6. And again, these numbers might look different, but if you reduce -4 over 6, you get -2 over 3. So in fact, the slope is the same. Okay, so we're going to talk about a slightly different way to find the slope of a line. But first, I want to practice the way that we know, which is to use the graph and just count the change in y over the change in x. So let's remember that our formula for slope is m equals change in y over change in x. So let's pick 2 points on this graph here, this line. Let's pick this point here and this point here. And we want to find the change in y over the change in x. Well, y is pretty easy. We're just going up 1 space, and x we're going over 1, 2. Now this is a positive line, the slope of the line is positive rather. So you would expect the answer is going to be positive. We go up 1 space, that's our change in y. And then over 2 spaces our change in x. But I want to do it another way, and I want to talk about what these points are. Like, let's talk about the coordinates of these points. So this point right here, the x and y coordinate, first you count the x, then you count the y. So we go over 1 and then up 2. So our first point is the point 1, comma 2. Our second point is 1, 2, 3, 1, 2, 3. Our second point is the point 3, comma 3. So I want to pause here and see if we could, I want to pause and ask you this question. Let's say we didn't have the graph and all we had is these points. How could you figure out that the slope is 1/2 just by using these numbers here? And I'm going to pause and take a minute for you guys to think about that. Okay, so there is another formula for slope, which is the same thing as change in y over change in x, but it looks like this. M equals y2 minus y1 over x2 minus x1. And all this means is, it looks complicated, but all it means is you're calculating the difference between the 2 y values and then the difference between the 2 x values. And that's exactly the same as what we've been doing in our graph over here, because we've been calculating the change in y and the change in x. Well, how do you find out how much two values changed? You just subtract them. So we're going to do, these are my 2 y values. I'm going to take this value minus this value, so 3 minus 2. And then my x values, 3 minus 1. 3 minus 2 is 1, and 3 minus 1 is 2. And we get the same answer in both places. So the slope of this line is 1 over 2. Okay, so this is an example of a question where they don't give you the line. You just have to be able to calculate the slope, and all you're given are 2 points on the line. But we have a formula for this, and we can use it to calculate the slope. So m equals change in y over change in x. And how do you find the change of two y values? Well, you just take one y value and subtract it from the other. And then same thing for change in x, you just take the second x value and subtract the first x value. Something I should say is that if you're going to consider this point your x1, then this has to also be your y1. And if this is your x2, then this has to be your y2. You can't like switch it up. Like you can't have this be x1 and this be y2. So just if you're going to make this be x1, make sure this is y1. If you're going to make this x2, make sure this is y2. So let's just plug into the formula. Y2 minus y1 is 7 minus 1. And x2 minus x1 is 5 minus 3. 7 minus 1 is 6. 5 minus 3 is 2. And we can reduce this because 6 divided by 2 is 3. So the slope between these 2 points is 3. Now it gets slightly more confusing if you have negative values to work with, but just know that the formula is exactly the same. So we want to find the slope between the points -4, -5, and -3, 6. I guess it really means the slope of the line connecting these points, but okay, so we're going to use our formula. M equals change in y over change in x, which I'm just going to write as y2 minus y1 over x2 minus x1. So these are our points here. If we make this x1 and y1 and make this x2 and y2, then we just plug in. The only little, that's an x, the only minor difficulty is that because we have negatives, we have to be really careful when we do the subtraction. So y2 minus y1, that's going to be 6 minus, and then y1 is -5. And then x2 minus x1, x2 is -3 minus -4. So what does it mean when we do minus a negative? Well, minus a negative is really the same as plus. So 6 plus 5 is 11. Same thing down here. We have -3 minus a negative. That's the same as plus. So we have -3 plus 4. And it's really helpful to think on a number line. If you're at -3 and you go up 4 spaces, you're at 1. So the slope between these 2 points is 11.